23, we have discussed previously how that cache will be useful, what are the how that performance can be increased, and then what are the challenges we are going to see, and then what what is cache. So that is going to be called as DASO with the IDLC for you. Okay. So here, for example, in this particular diagram, we have multiple cores, core 1 to core n. Every core will have its own private cache. So that is going to be the cache. And then we have some local memory as well as private cache, all those things. So in case shared, so that memory is going private cache, that all the memory is going to be shared among that multiple cores. So each will have its own directory. So we have, for example, memory going to be shared among that CL. So what ultimately I'm going to say, whatever memory we have, it is going to be shared with each and every core. So we have a particular memory block that is going to be shared with each and every core whatever available in this particular network. So that is the main information you have to know. And then we are going to have interconnection network. So already I told you each and every core is going to be connected with interconnection network. So that is why we are going to follow that ring topology, or otherwise we have a star topology, something like that. So in that case, already I told you we have that presence of bit, a group of bits is going to specify whether it is going to be that particular block of memory is going to be in valid state, or otherwise whether it is going to be invalid state. Along with that, here we have one modification. We have something called as dirty bit. So dirty bit is going to know it is whether that particular going to be state, a particular block of state is in exclusive state. So in that case, that dirty bit is going to specify this particular block is in exclusive. So which means that it will have that whole permission. It will have that the latest thing. So we are to avoid that stale copy. This dirty bit will specify this particular block is going to be exclusive. In that case, so that information is going to be shared among that with that particular bus. So in that case, that remaining that particular cache, but that remaining memories will invalidate that particular block. All those things we all know. Okay. So in that case, we have, for example, already I told you maintain the state information explicitly. So we have a cache controller. We have a cache controller. It will explicitly maintain that cache concurrency policy. The cache replacement policy will maintain the state information explicitly. So which means that what is going to be the state, associate state information with each memory block. So we have a directory. So we have a memory block. The memory block will specify whether this particular block, what will be the state of that block. And then we are going to record that state of each block in that cache. So we have that cache information. So information is going to be maintained by that by a particular directory. So whenever we are going to have on cache miss, you know what is meant by cache miss. So this particular, for example, a particular core request a particular memory, a particular data, it will check with that cache. So if that cache, the data is not available, then it is going to be called as cache miss. So if that particular core requests a data, in that case, it will check for in this particular cache memory address. If it is not available, in that case, it is going to be called as cache miss. So what it will do, suddenly it will put that message. So previously, so it will, for example, in Snoop-based protocol, that so what it will do means that particular code it will request. So in that case, that is going to be kept in the bus. So in that case, that is no base that bus. Each and every core we put the transaction available, that particular core, it will get the data. So this is fetched by the particular core. This is that thing will be happened by the previous transaction. So here also going to be that, but one small modification we are going to do. That modification we are going to see. Any doubts here? Again, I will repeat. If you have any doubts, you can ask me, please. Done in Snoop-based protocol. So for that, we have a three-state diagram, transition diagram for read miss transaction, and then write miss transaction. Whether that state is in invalid, whether the state is shared, whether the state is in exclusive state. For that, we have come across that transition diagram. That is, I have taken in the previous class. So, you have any doubts? Please ask me. Anyone? You can unmute and then tell me. In, for example, what is the basic difference between Snoop-based versus directory-based? If you have any basic doubts, I have explained about what is Snoop-based, what is directory-based. Any doubts in that earlier difference before going to start the transition diagram? If you have any doubts, you tell me. Any doubts? Shall I proceed? Shall I proceed to the next line of this particular slide? Hello? Okay. So I will proceed to that next step. So in that case, if any catch miss occurs, so in that case, what happened? For example, in that core N request a data, and then if it is catch miss, and then it will put that transaction within that interconnection network. So in that case, that it will check for whether that valid block in which the catch copies. So that for example, that the interconnection network send that messages to each and every catch block whether the copy is available or not. So here the message is transacted. So previously we will put that message on the in terms of transaction in that bus. But here the interconnection network will send the messages to each and every block whether this copy is available or not. If it is available, further action to be taken from that particular block. So which means that according to the state of that particular memory block, further action can be taken, whether it is invalid or valid or otherwise it is modified exclusive. According to that, the action will be taken. That is going to be the second one. Determine what further action need to be taken. After that, we are going to perform set of transaction to keep the directory up to date. So once after that, for example, whether we have to invalidate or otherwise whether we have to fetch the data, once whether we know the state of that particular memory block, we are going to update that directory. Okay. So once if I know previously it is going to be that shared. So in that case, who are all going to be the sharer? That information is going to be updated in the directory. Previously P1, the core 1 is going to be the sharer. Now the core 2 is going to request the data. And so in that case, core 2 is also going to be in that list. So all this transaction is going to be updated to the directory today by that. Okay. So this is these three things are informed. These three things are slightly modified to the, for example, what we can directory based coherency protocol. So in that case, first we have to check whether the block is available or not. In that case, if it is not available, I will send a transaction. After that, each and every core it will check, receive these messages. According to that, it will take the necessary action. After that, I will update according to that action. So in that case, here we are going to have three types of node. So each and every node we are going to have home node, owner node, request node. So three nodes are available. This is one difference. So in that case, what is going to be a home node? Whose memory chunk the block is allocated? That is going to be called as home node. So for example, C1, the core 1 requests a data. So if it is not available, so in that case, it will request that, for example, request for the data. So in that case, what it will do? It will place a message. So whether the catch controller will place the message in the interconnection network. So in that case, the core 4 will have that memory information. Core 4 will have that data. So in that case, the home node is nothing but C4. So C1 is nothing but request node. That home node is going to be the home C4 will be the home node for order to send the data. After and then here we are going to have one more thing is going to be called as owner node. So what is mean by owner node? It means I want to recall the previous information. So for example, previously we have discussed cross core 1, core 2, core 3. In that case, core 1 requests the data which is not available. So in that case, it will place the transaction. After that, it will get the data. Similarly, core 1, core 2, core 3 also. So again, it will request the data. Now it is going to be computed. Now it is going to be computer means now the data is going to be modified by C3. In that case, that is going to be called as owner node. So in that case, what it will do, it will send the invalidate signal to the interconnection network. So in that case, the remaining core, it will check for, it will receive the message and then it will invalidate the data. Invalidate the data wherever available, whether the particular memory block is shared in that particular chunk or not. Now, you have any doubt in these three: home node, owner node, request node? You have any doubts? You can ask me, please. Then we can move to the next state transition diagram. You have any doubts? Whether you have any doubts in home node, owner node, request node? You have any doubts? Hello? Any doubts? Shall I proceed? Anyone can unmute and then tell me, please.
Yes, sir.
Whether you have any doubts in home node, owner node, request node, whether it is clear. புரியலனா புரிஞ்சிருச்சுனா நான் அடுத்ததுக்கு போவேன். புரியலனா திருப்பி I will repeat that again what is home node, owner node, request node. எக்ஸாம்பிளோட திருப்பி சொல்லணும்னா சொல்லுங்க. Hello?
Clear, sir.
Thank you, ma. Okay. Now we will go to the state transition diagram of for an individual catch line. So previously we have discussed the catch line. So previously we have three-state diagram, three-state for catch coherency protocol. No, so based on Snoop-based protocol. So here also we are going to have invalid, write, modify, all those things. The same diagram what we have discussed with the previous class is same. But what is that thing is, if you refer to the previous diagram, if you refer here is everything is going to be called as, for example, we are going to have place a read miss on a bus. But here what we are going to have is we are going to send a read miss message. That is a difference. So in directly based protocol, again I will just see CPU read and then we have a place a read miss on a bus. But here we have to go for place a read miss, CPU read miss and then send a read miss message. That's all. Instead of putting that read miss bus on the bus, here we are going to send a message that will be transmitted by this catch replacement policy by the interconnection diagram, and then according to that they will receive that message. So previously that particular node, each and every node will snoop that, but here each and every node will receive the message by the interconnection network. The network will send a message to each and every core. According to that it will be reacted. So according to that CPU read miss, CPU write miss transaction based on the individual block, whether that particular block is invalid or otherwise particular block is shared. So whenever that particular block is identified as invalid, whenever we are going to perform a read miss transaction, what will be the next step? Whenever we are going to get that write miss transaction, what will be the next step? So according to that we have modified the diagram. But here everywhere we are going to see, instead of seeing, for example, we are going to see that place a write miss on a bus, but here we are going to see your place send a write miss messages to the interconnection network. That is a modification we are going to see in this particular diagram. Now we are going to see a state transition diagram based on directory based protocol. In that case, a particular block is identified as uncatched and then shared as well as modified. For that, what we are going to see is what are the transactions we are going to see. So first, we are going to, for example, if we have a particular request by a node 1. So C1 request a message, C1 request a data. If it is not available, so here what it will do, it will send a read miss transaction. So read miss transaction. So in that case, what happened means it will be sent to each and every core with the message. So in that case, core 4 is eligible, core ready to request. So core 4 can eligible to send the data. So in that case, core 4 is nothing but which node? Can you tell me? If core 4 is going to send this data, so in that case, what is the name of that particular node now? C1 is nothing but C1 requested a node data. In that case, C1 is going to be requested. In that case, it is going to be called a request node. Now core 4 is going to provide the data. So in that case, whether the core 4 is home node or the core 4 is owner node. Anyone, can you tell me whether it is home node or whether it is going to be a owner node? Anyone? Whether I have core 4 is call it as home node or otherwise whether it is going to be called it as owner node.
Sir, home node.
How you are going to fix whether it is going to be home node?
Home node contains the data which the node the C1 is requesting.
Yeah, very good. But the thing is, we have to check the state of the data, state of the memory address, whether it is going to be whether it is going to be in exclusive state or otherwise it is going to be in any other state. According to that only we have to confirm whether it is going to be home node or it is going to be called as owner node. So as of now, it is going to be in that state of uncatched. So in that case, which means that it is invalid. So in that case, it is going to be called as, for example, it is invalid state. In that case, it is going to be called as home node. Whether it is going to be in exclusive state, then it is going to be called as owner. So here, what is meant by uncatched? So uncatched is nothing but, so for example, there is no shared information in this particular private cache. So whatever that private cache which is available to each and every core, it won't get that. So for example, it is not available in that private cache of every core. So in that case, that is going to be called as uncatched. So where it is available? In that case, it is available in the local cache. So you see, so previous diagram. So in that case, this is going to be called as private cache. This is going to be called as local memory. So here, this each and every, whenever we are going to say it is uncatched, means from C1 to Cn, whatever the cache data is for whatever the cache is available, this cache will not having that information. Then it is going to be called as uncatched. Whenever we are going to request a data which is not available in any one of the cache within that C1 to Cn, then it is going to be called as uncatched. Purida, in uncatched enangiradhu purida? Whether it is clear? That is going to be called it as uncatched. So in that case, what we are going to do is, we are going to place the read miss and then we are going to send that information, share as information. In that case, now that local memory is going to send that data. So in that case, we are going to send the data value reply to the particular core. So P core 4 is going to give that information. Now the sharer information is P1. So P1 will now have the data. Then it is going to share. Anyone can request the data. now that P1 is eligible for Nara to share that information. So that is for read miss transaction. Similarly, here we are going to have, whenever we are going to, for example, we are going to, C1 is going to request a data. In that case, that particular block is going to be in, for example, it is going to be in shared state. So what happened? We are going to, for example, we are going to check for the read miss, then send, for example, C1 data is not available. In that case, it will place the messages. In that case, C4 is going to give the data. So in that case, what it will do means, whenever we read miss transaction, particular block is in shared state. So in that case, it is going to maintain in the same data. But now that it will get from C4 and then it will share the data. Now that, for example, C1 as well as C4 is eligible for in order to give the data. That is going to be the updated value. That is for read miss transaction. Okay, so carefully listen to this one. So we are going to have read miss transaction. At that time, that particular block is in shared state. We are going to give the data. We are going to share the sharers list. Okay, now again, now we are going to perform a write miss transaction. Now we are going to go for the next thing, write miss transaction. So whenever the core one request request a data, write request. If, for example, core one writes a write transaction. In that case, it will check for write miss. So in that case, what happened is, so here, what happened? It will move to the modified state. Why it is possible? So for example, already that particular state is in modified state. So in that case, it will invalidate. So invalidate whatever that memory block is going to be now invalidated, and then we are going to place that value. So we are now, due to some computation, that particular state is going to be in modified state. So in that case, I will invalidate that particular memory block, and then I will place that messages to the interconnection network. So that is going to be that case, invalidate the channel. So again, this is for shared. So I am going to get that memory block that is in shared state. So now I am going to check for a block which is going to be in modified state. So modified state means C1 requested the data, C4 is not having that information, but C3 is going to be in an exclusive state. So at a time, you all know one particular memory block is going to be in exclusive state. Now here we have a transaction. That particular time, this C3 is going to have that particular exclusive state. So in that case, what happened? So in that case, that it will give you that information, and then it will change that value, change that state C1, C3, and then C4 to a shared state, and then again that particular, now that once it give the information, that particular block again it will move from the exclusive state to shared state. Once it share that information, the new data, now that particular block is going to be moved to exclusive state to shared state. Okay, so that is going to be given in this write miss transaction. Okay, now we are going to see that one. Whenever we are going to so for example, we are going to check for a particular state, then it is going to be in modified state. So in that modified state, so in that case, we are going to say, for example, we are going to raise a dirty bit. So dirty bit is nothing but, so in that case, for example, a particular block is going to be in dirty block. So in that case, we are going to share that information. Once it is shared that information, in that case, we are going to remove from that, we are going to remove that particular data. So in that case, now that particular block is going to be moved to in uncached state. So we are going to write the data. After we are going to write that sharers list, now that particular state is going to be moved to uncached state. So these are all the state transition for a directory based protocol. So these are the transactions we are going to have for a state transition diagram for directory based. So what we are going to see here is whenever we are going to put a right validation, invalidation, coherence-based protocol, first, what is the basic changes between the previous one versus the new one is, here we are going to not put that transaction on the bus. Here we are going to put that in the, we are going to put that in that message. We are going to put that in message. Now we are going to start from uncatch, while instead of validate, we are going to have that state in terms of uncatched, and then we are going to have shared and modified state. So we are going to send that messages, and then according to that we are going to get the data. According to that, I will change that state in the directory. So that is the modification we are going to see in that state transition diagram. Any doubts in this, you can ask me. Remaining things are same. Only thing is, we are going to, instead of put the transaction on the bus, here we are going to put that send that messages based on that interconnection diagram. That network on chip will send that messages to every core. But one more thing, here previously we have a limited core. Here we have the core is going to be n. That information also you have to read. Any doubts in this, you can ask me. So if you clearly watch the video today's class as well as previous class, you can easily explain about this particular question in your thing. Okay. The next one more information I want to tell you. You all know what is the pattern of your NSOMS examination. You are going to have 20 marks. So 20 marks will be either 10 marks, 10 marks, or otherwise you will get 120 marks actually. So in that case, you have 20 minutes time. According to the 20 minutes, you have to eligibly you have to write that thing what you are going to have. Okay. So don't get panic. So whatever that, for example, I want to tell you, whatever that descriptive questions what we have asked, that kind of questions will be asked. That my pattern will be asked in your NSOMS examination also. So we will give you soon. We will give you what are the questions you have to read, and then we will give you the link. So previously, for example, I will also explain. So I will also post the link from my fellow colleagues what they have discussed in their classes. Then it is easy for you to get that information. Then it is easy for you to recall all those things in different aspects. Then you can easily get that answer. Okay, so okay, so hello. So you will get answers. So we will post the link hereafter. We will close the link. So you just check the GCR and then open the link. If you have any doubts, if you have any issues, you will ask me. Okay. So we have a limited time. So for that we are planned for. We will take different topics, whatever the left out topics shared by ourselves, our fellow colleagues, and then we will post all those things, all the videos in your GCR. So you can watch it. So because once the third unit gets over, the fourth unit is going to be a memory. Already that memory, all those things you have studied in your COCA. So what we are going to do is again, but we are not going to omit that. But what we are going to do is we will record that video and then we will post that in the classroom. That is our plan. So we will give you the, for example, solution for your CA exams also. So in that case, you can easily complete that CA. So it is very easy. Once if you understand, go through the video properly, you can easy for you to answer. The next one is whatever the questions asked in, for example, CAA, sorry, not CAA, that the exam what we are conducted, that pattern, if you concentrate more, definitely you will get good marks. Any doubts you can ask. If you have any doubts, you can ask me now. So next class we will start with the next topic, synchronization. That is going to be the end of your unit 3. Any doubts you can ask me now. presentation, and then we are going to have, yeah, please give set of questions. Yeah, definitely we will give. So we will give you that question also. Don't worry. Set of questions, because who is going to take the question paper or review doesn't know. But we will share you the set of questions. It is possible questions we can share, and then we will share you the link also. Okay. So this I will stop today. I will continue in the next class. Any doubts you can ask me. Otherwise you can leave. Thank you.